Welcome to solverfy.
Hello students, for the given question, the model of selection you provided is a basic example of natural selection acting on a single gene with two alleles in a diploid population. The fitness values of the three genotypes capital A, capital A, capital A, and small a are given by 1, 1 minus S1 and 1 minus S2 respectively, where S1 and S2 are the selection coefficients against the capital A and small a alleles respectively. Small p represents the frequency of the capital A allele in the population, and small q represents the frequency of small a allele. Since there are only two alleles, we know that p plus q equals 1. To calculate the change in p after one generation of selection, we can use the Hardy-Weinberg equation, which is p square plus 2pq plus q square equals 1, where p square represents the frequency of capital A genotype, 2pq represents the frequency of capital A small a genotype, and q square represents the frequency of small a genotype. Starting with given frequencies of each genotype, capital A 100 by 285 equals 0.351 or approximately 0.35. Capital A small a 150 by 285, which will be equals to 0.526, and small a 35 by 285 equals 0.123. We can calculate the initial frequency of capital A allele small p by adding half of the capital A small a genotype frequency to the capital A genotype frequency. P equals 0.351 plus 0.5 multiplied by 0.526 equals 0.614, and the frequency of the allele Q is 1 minus P, which will be equals to 0.386. Next, we need to calculate the expected frequencies of the capital A and small a alleles after selection. P dash equals P square 1 minus S1 plus 2pq plus P q 1 minus S2. For Q dash, it will be equals to Q square 1 minus S2 plus 2PQ plus PQ 1 minus S1. Using the given values of S1 and S2, P dash will be equals to 0.614 square 0.65 plus 2 into 0.614 multiplied by 0.386 plus 0.614 multiplied by 0.386 multiplied by zero point 0.4, which will be equals to 0.580. In the same way, Q dash will be equals to 0.386 square multiplied by 0.4 plus 2 multiplied by 0.614 multiplied by 0.386 plus 0.614 multiplied by 0.386 multiplied by 0.65, which will be equals to 0.420. Therefore, the change in P after one generation of selection is delta P equals P dash minus P, which will be equals to 0.580 minus 0.614, which will be equals to minus 0.034. This indicates a decrease in the frequency of the ALL due to selection against it. I hope you find the video useful. Thank you.